So we will solve this smallest missing non-negative integer after operations lead code problem. So what is the problem statement? You are given a zero index integer array nums and an integer value. So it is defining one operation which we have to perform. What is that? We can add or subtract value from any element of nums. Okay, either we can add or subtract, and we can do this operation any number of times. Okay, so it has given example like 1 2 3 and the value is 2. Then you can choose to subtract value from nums 0. So if we subtract this, it will become -1. It will become -1. Okay, now it is defining maximum excluded. What is this entity? It is defined as like the smallest missing non-negative integer. So basically it 0 1 2 like this. The smallest value possible is 0. Okay, so we have to check, we have to find which is the smallest non-negative integer which is missing. Okay, so like this, if this is example, here we can see if we see is 0, but what if we add 2 here? It will become 1. Okay, 1 2 3. Okay, yeah, this was this. So here we can see further, if we subtract 2 from any one of them, okay, it can make 0. Okay, I mean they are just simply explaining the max concept. Okay, yeah, so for this max is 0. Okay, got it. Written the maximum max they have said, right? Why they have said maximum? Because we can perform this operation any number of times, adding and subtracting. So we have to form such an array after this operation that the this max should be maximum. Okay, why like what will be the minimum? What we could have done is simply we know minimum answer would have been 0. We would have made all the elements greater than 0, then our answer would have become 0. That's why, I mean, then it would have become a very easy problem, right? So that's why they have like asked maximum. Okay, so what's the intuition first of all after understanding the problem statement? So let's see. Okay, so basically you have to find the smallest number which is missing, right? So you will say, okay, let's go, and the smallest possible number is 0. Okay, now we have to make sure like that our answer should be maximum. So we will try that if 0 is missing in the array, we should somehow make it there after our n operations. Okay, if 0 is not there in our array, we have to make it. Okay, and if it is not possible to make 0, then 0 is our answer. Same for 1, same for 2, same for 3. Okay, we will keep finding, and the point at which we could not further uh, develop that element, then that will be our answer. So our intuition is like to smallest number, like the given array, we have to somehow convert them to their least possible number. Okay, so how we can do that? So when we repeatedly subtract a number, it is equivalent to division basically, right? Here, so here you can see like I have written, if we are subtracting b from a n number of times, like, so what could be the least possible number which we will be left with at the end? So this is what basically our modulus operator tells, the minimum possible number which will be left after subtracting b the maximum possible of times it is possible before it gets non-negative, before it gets negative. So what will be our approach? Let's see. Okay, let's say we have this example. Let's try to understand this. So and let's say our value is 5. Now you will say firstly we have to find 0, right? Firstly we have to find 0. Do you see anywhere 0 here? No, right? You will say then we have to make it 0 somehow. We have to perform operation, and value is 5. You see 15. You know 15 modulo 5 is 0. So basically if we keep subtracting 5 from 15 we will get 0. Okay, so it means 0 is possible. Okay, now next number we will check is 1, whether 1 is there or not. Okay, we found the, now this is used up, so now you cannot do any operation on this, it is gone. Now we'll check for 11. Okay, we say that 11 modulo 5 is 1. Okay, so 1 is also possible. Similarly 12, so 2 is possible. We'll check for 3. We can make uh, we can make 3 from 13. Now we'll check 4. 4 can be made from here, it is also possible. Now you see modulo of here is again 0. Okay, it is again 0, but what we want 5. But you know, as I have shown here, like 5 can be created from 0. How? If we have a 0 we can add 1 time 5 to get 5, right? So it means firstly we converted this to 0, then this 0 to 5. We can perform that operation n number of times, right? So basically you can think like we did this, or you can, another way what we can think instead of searching 5, let's search 0, which is 5 modulus value is 5, so it will 0. Okay, so but 10 was already consumed here, so we need to track basically how many 0 are there, or right, because 1 is consumed we cannot use it again, right? So once it is consumed we have to subtract it, right? Similarly for 6, so instead of searching 6 we will search for 1. Why 1? Hope you got the idea. So I mean simply I have written like nums of I can be written in this form, like just wanted to give like mathematical expression. Basically what we are doing, we are expressing nums of I in terms of value. So what these modulo what we are finding, we are saying now we can search, instead of this we are search this. So how it is possible? Because uh, because uh, because this operation we can perform n number of times, and after this we can add this modulo value to it to get nums of I basically. Okay, so let's look at the code. Okay, so this is n, like length of our array. Now what we will do, we will convert all the numbers to their modulo of value, right? Why we are doing this? You, as I said, instead of searching the number we will search them modulo, and so Here we will search the modulo 0, 1, 2, 3, 4, and only these modulo will get like repeated, basically 0 to n minus 1. Up to this number only our array can produce, right? Because its length is n. So answer will be anything from like 0 to n minus 1. And if all these numbers are present, that's all the let's say we have an array which is 0, 1, 2, 3, 4, then our answer will be 5 at max. So our answer will be, we can say, less than equal to n. This is fixed. Okay. So we find the model of all our existing value. We converted them to our counter dictionary. Hope you know counter dictionary. It's a way to create a frequency dictionary out of our list. Okay, now this is our answer. We are going to iterate from 0 to n, because as I said, our final answer will be less than equal to n only, right? Now as I said, instead of searching the value, we will search the modulo, right? Now instead of searching the value, we'll search the modulo of the value. Okay, so we convert the value to modulo, and now we are searching whether it is present in our dictionary or not, and also the counter should be greater than 0. If it is there, then we will use it, we will consume it. Otherwise we will otherwise if it is not present, it means this is our answer, right? We will return the answer. Okay, so here you can see we are iterating the num array only once, here also and here also. And we are no and space, for space we are using this dictionary, so our space complexity is O of n. So this was like easy problem only. Okay, hope this was clear. Thank you. You can ask doubts in the comment.